morning to everyone. In the previous class, we have discussed about Aristotle's fallacy and Galileo's experiment. And today we're going to discuss the most important part of this chapter, that is Newton's law of motion. As you all know that Newton gave us three laws of motion. Accordingly, Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So we'll discuss first Newton's first law of motion. You write down Newton's first law of motion. Newton's first law of motions. Newton's first law of motion we are going to discuss. Newton's first law of motion is also known as can also be told as the inertia. It is also similar with the definitions of inertia. And we all know what is inertia. Inertia is a property of object where we doesn't want to change our position, state of position. So whether you are in motion, whether you are in rest position. Okay, so according to Newton's first law of motion, we can say, you write down, a body want to continue. A body want to continue a body wants to continue its state of rest or uniform motion unless it does not a body wants to continue its state of rest or uniform motion unless it does not disturbed by any external forces, any external unbalanced force. So this is the Newton's first law. A body want to continue its state of rest or uniform motion unless it does not disturbed by any external unbalanced force. Okay, so this is Newton's first law, or you can also write like that. A body wants to continue its state of rest or uniform motion unless an external unbalanced force act upon it. This is Newton's first law. You can write. That means, what does it mean? What does Newton's first law means to us? That a body that is in rest position, it wants to stay in rest position, and a body that is in uniform motion, it wants to continue its motion unless any external forces are acting on that particular body. Since I am standing here, so I can take the example of it. Suppose this is a body, and this body is at rest position. That means rest position means the velocity of the body is 0. Velocity of the body will remain 0 unless an external unbalanced force does not act upon it. Suppose this is a body, this body is moving Okay, this body is moving in some direction. Now this body will keep moving unless you don't apply here an external force opposite to it. That means, suppose this body is moving with some velocity v. This body is moving with some velocity v. Now this body will keep moving with velocity v until and unless and the external force does not act upon it. Okay, once the external force act upon it, this body will automatically stop. That means a body wants to continue its rest position if there is no external force is acting on it, and a body wants to continue its uniform motion unless an external force is acting upon it. That is the same thing. Okay, so this is quite similar with the inertia. So this is Newton's first law of motion. Now mathematical expressions of Newton's law can be derived by the Newton's second law. Once you study the Newton's second law, then we can derive the mathematical expressions of Newton's first law. In one word, you can also say that Newton's first law is a special case of Newton's second law. Derivations of Newton's first law is a special case of Newton's second law of motion. So this is Newton's first law. I think you have cleared. Very simple thing. A body at rest will be at rest. A body in uniform motion will be at uniform motion unless an external force is acting upon it. Okay, so we'll go to the Newton's second law of motion. We'll come back for the mathematical expressions of Newton's first law after Newton's second law of motion. So what is Newton's second law of motion tells us? Newton's second law of motion. Newton's second law of motion we will study. So before going to know the Newton's second law, we should know one term that is called momentum. You all know what is momentum, so we have to know about momentum. You please write down. Momentum is denoted as P. Remember, momentum is denoted as P. So you can write momentum. It is the product of mass and velocity. It is the product of mass and velocity, and that is expressed as momentum P is equal to mass into velocity, and it is a vector quantity. Okay, this is momentum. Momentum is the product of mass and velocity, that is expressed as P is equal to mv, where m is the mass and v is the velocity. SI unit of momentum P. What is the unit of momentum? This is mass. Mass will be kilogram, or kg. Velocity is your meter per second. So kg meter per second will be the SI unit of momentum. Is that clear? For mass, SI is kg, and for velocity, SI is meter per second. That is your momentum concept. Now we'll go to the Newton's second law of motion. What is Newton's second law of motion? Right, according to Newton's second law of motion, the rate of change of momentum, okay, is directly proportional. The rate of change of momentum is directly proportional to its applied external force. as you can write, the rate of change of momentum, the rate of change of momentum of a body, okay, the rate of change of momentum of a body, this word was missed. The rate of change of momentum of a body is directly proportional to its applied external force, okay, and its direction, is same in which the force act. Okay, this is the Newton's second law of motions. You can write what I'm saying. The rate of change of momentum of a body is directly proportional to its applied external force, and its direction, okay, and its direction is same in which the force acts. That means direction will be on that way in which way the external force act. Am I clear? This point is very important to know, that its direction is same in which the force act. Understand? So this is your Newton's second law of motion, and mathematically it is expressed as, how can it express? Mathematically you can write, mathematically it expresses F is equal to ma. That means we can find the mathematical expressions of force from Newton's second law. That is, force is equal to mass into acceleration. Is that clear? So this is your Newton's second law of motion. Now we can derive this F is equal to ma. Okay, how we can derive? Before that, you again read these definitions. So the rate of change of momentum is directly proportional to its applied external force, and its direction is same in which the force act. So we'll write the derivations of F is equal to ma. You write derivation of F is equal to ma, or you can write the derivations of Newton's second law of motion, that is F is equal to ma. Now if we derive these things, okay, so you can write, we know that, or we have just found that if F is the external force that is applied on the body, then F will be directly proportional to rate of change of momentum. Rate of change of momentum means what momentum we found? That momentum was P is equal to mv. This is your momentum we found. Okay, so if I write this will be dp upon dt. This is dp upon dt. So this is rate of change of momentum. That means that this is, if I consider F is going to be your external forces, then it will be directly proportional to rate of change of momentum, that is dp upon dt. Now again we can write, so F is proportional to d by dt of, in the place of p I can write mv. Okay, in the place of p I can write mv. Now there is a formula that most probably you will find in mathematics. If we consider d by dx of uv, okay, d by dx of uv, this is a formula, so it will be like that. You will find in mathematics, this will be broken as u dv by dx, okay, u dv by dx plus v du by dx. So this is a formula. you should remember it, and in mathematics you will find it. that d by dx of ub is equal to u dv by dx plus p du by dx. So if I break this formula with respect to time, so it will be like that: m dv by dt, m dv by dt plus p dm by dt, like that we can break it. So again it will become f proportional to m dv by dt. dv by dt is your acceleration. We know that dv by dt is the acceleration. This formula also we have got that acceleration can also be expressed as dv by dt, that is rate of change of velocity. So in the place of dv by dt we can write a plus, this is your p dm by dt. dm by dt will be 0 because mass is constant in this case. So derivations of mass, a constant term, is always 0. Derivations of a constant term is always 0. So in this case mass is constant, so dm by dt will be 0. Understand? Mathematics, in mathematics we will find it that derivations of constant term is 0, so mass is constant here. So in this case f will be proportional to ma. Now I can take a constant, that is f is equal to k ma, where k is a constant, where k is constant, and in SI system that means the value of k is always 1. So we can write f is equal to ma, hence proof, since k is equal to 1. Okay, the value of constant of k is equal to 1. So this is f is equal to ma, and derivations of Newton's second law, that force F is equal to ma. Very simple thing. The rate of change of momentum is directly proportional to its applied external forces, and direction of it will be same in which the force acts. Okay, so this is derivations of Newton's second law. We can derive this F is equal to ma by so many processes. I have used this process because in class 9 you have proved this particular formula in a very simpler way. So this is your a little bit of standard process to derive it. Now as I told you that we can prove the Newton's first law of motion with the help of Newton's second law of motion. So how can I do it? Let us see. I also told you that Newton's first law of motion, the derivations of Newton's first law of motion is a special case of Newton's second law of motion. You remember it, you can write down. The derivations of Newton's first law of motion is a special case of Newton's second law of motion. So we can write that derivations of Newton's first law from Newton's second law. This is you write down. Derivations of Newton's first law from Newton's second law. So what we found in case of Newton's first law, that in Newton's first law we found that F is equal to ma. This was Newton's first law. So in this case, if I write that this is F, if F is your external force, if external force, suppose I can also write that F is equal to I can write this is your acceleration. This is acceleration. Acceleration can also be written in simpler form. How? We can write v minus u by t. Instead of writing dv by dt, we can also write v minus u by t. I am writing this in order to fix the first law to make you understand. So in this case, what we can do now, see, if I multiply these things, ft is equal to mv minus, this is p minus u. So ft is equal to mv minus mu. Okay, mv minus mu, or you can leave in the first line only. Okay, so in this case here, if Now if F is 0, that means what was according to Newton's first law, that if there is no external unbalanced force, then that body is going to be stay at rest if it is in rest, and the body is going to continue its uniform motion if the body is in uniform motion. But external force concept of that is what, that external force was 0. So if we consider that external force is 0, so what will happen, that this value will become 0. So 0 is equal to mv minus mu. So if I write from this equation that v minus u is equal to 0, or you can write that v is equal to 0. That means, what do you mean by v is equal to 0? That initial velocity and final velocity is 0. That means there is no change of velocity. No change of velocity. Why? Because there is no applied external force. If there is no change of velocity, then there is no acceleration. Am I clear? That means you can consider, if net force is 0, if net force acting on a body is 0, then there is no acceleration. You mind the point. If net force is going to be 0 on a body, then there is no acceleration. And if a body is moving in uniform linear motion, then also acceleration is 0. That means in this case acceleration is 0 when there is no net force. That means if net force acting upon the body is 0, then no acceleration. And if that particular body is moving in a linear uniform motion, then also there is no acceleration. Okay, so that is how we can prove that Newton's first law from Newton's second law. So finally we can come to know what is Newton's first law and what is Newton's second law. What does Newton's first law say? Newton's first law say that in the absence of any external applied external force, a body will continue its rest position, or a body will continue its uniform motion if it is in motion. If it is in rest position, it will be at rest. If it is in uniform motion, it will be in uniform motion if there is no applied external unbalanced force. What is Newton's first law will also say that we can also assume from Newton's second law that if net force on a body is 0, then there is no acceleration, and if a body is moving in uniform linear motion, then also there is no acceleration. But what is Newton's second law? It is something different. That the rate of change of momentum of a body is directly proportional to its applied external force and the directions of its shape in which the force acts. Okay, so this was Newton's first law and Newton's second law. Newton's first law, second law can be expressed as F is equal to ma. Okay, thank you so much. So this is a very important formula to know for you, and there are so many examples of Newton's first law and second law. Okay, so in the next class we'll discuss about Newton's third law. Until then, stay tuned in my channels. Thank you so much.